Hi, this is week 21 of AP Physics, and we're going to go ahead and start Unit 5, which is called Momentum. Now, what exactly is momentum? Well, let's go ahead and have a discussion what it is before we get started with our lesson. Picture yourself running very quickly. If you all of a sudden decide to come to a full stop, it's going to take a little bit of time and distance for you to come to a full stop. Why is that? Why can't you instantaneously come to a full stop? Because you have momentum. So that's what we'll be talking about today. So let's go ahead and get started. For our agenda, our lesson focuses on two parts, momentum and impulse. For our lesson objective says students will understand the relationship between momentum and impulse of an object in motion. So momentum and impulse. So it's the linear momentum, which the symbol is P, of an object of mass m moving with a velocity v is a product of its mass and velocity according to that equation. So you just got to multiply the mass and its velocity of the object, and that was going to go ahead and give you the momentum. The relationship between net force and momentum can be derived using this formula. So starting from the left-hand side, we have our net force. So for our net force, that is equal mass times acceleration according to Newton's second law. And the acceleration, we can go ahead and derive, well, acceleration is really a change of velocity over time. And we can go ahead and simplify the formula a little bit, as you see on the right-hand side. So the change of an object momentum divided by the elapsed time equals to the constant force acting on the object. So what is impulse? Impulse, symbol for it is I, is a measure of the effect of the force over time. If a constant force acts on an object, the impulse delivered to the object over a time interval is given by this equation where I equals force times time. So the amount of force you're putting times time, that gives you the impulse. Now the unit for momentum and impulse are both the same, kilograms times meters per second. The impulse momentum theorem states that the impulse of the force acting on an object equals the change in momentum of the object. So impulse is the same thing as force times time, which is also the same as the change in momentum, which is mass times velocity final minus mass times velocity initial. All of those are vectors, so whether they're going to the left or to the right, positive or negative, that is important. To simplify these calculations, the average force used for our calculation is going to be force average is equal to force average times time is equal to change in momentum. Now, how do you get the average force? Now, for the average force, let's say that you have this diagram here on the bottom left corner. And for the average force, we're going to go ahead and look at the total force over the time interval it takes place. So notice that it is a curve, all right, but the average force is just the halfway point. So that'll be our force average, as you see it here on the right-hand side. Now, that force average is going to give you the total force that you can use for the impulse. Or for the impulse, it's going to be, if you multiply the average force, which is again halfway down the curve, multiply times the time interval. So that gives us the area under this square right here. So the magnitude of the impulse delivered by a force during the time interval is equal to the area under the force versus time graph. Up next, we're going to go ahead and take care of some examples and a couple of problems.
In example number 1, we're asked the following question. A golf ball with a mass of 5.0 times 10 to the negative 2 kilograms is struck with a club. The force of the ball varies from 0 when the contact is made up to some maximum value when the ball is maximally deformed, and then back to 0 when the ball leaves the club face with a velocity of 44 meters per second. In part A, they want you to find the magnitude of the impulse due to the collision. Alright, so let's go ahead and get to work on that. Some of the values that were given to us, the mass of the ball, and it is 0.05 kilograms. The initial velocity is 0, the ball is stationary, and its final velocity is going to be 44 meters per second. In part B, they ask you to estimate the duration of the collision, and they give us the distance that the club and the ball are in contact for a distance of 2 centimeters, which is 0.02 meters. And in part C, they ask you to find the average force acting on the ball. So let's go ahead and go back to part 1. So let's just find the magnitude of the impulse. Alright, impulse on this. Impulse is the change in momentum. Alright, so our momentum, of course, is mass times velocity. So our change in momentum is really mass times velocity final minus velocity initial. And that's going to go ahead and give us our impulse for part A. We have the mass of the ball, the final and initial velocity, so it's going to look like this. The mass of the ball, it is 0.05 kilograms multiplied times 44 meters per second squared minus 0 meters per second squared. So we go ahead and put that into the calculator. It's going to go ahead and give us the following. 2.2 kilograms per meter squared. And that is the impulse for this problem. Alright, so that takes care of part A. Up next, we're going to go ahead and take a look at part B. In this one, they ask you to estimate the duration of the collision if the club and the ball are in contact for a distance of 2 centimeters. Alright, which is again 0.02 meters. Alright, so the duration of the collision for that one is going to be the following. If we know that the average velocity is equal to displacement over time, so the time is what we're looking for, which is how much time the ball and the club are making contact. Alright, so we're going to go ahead and move this around a little bit to solve for the time, so it's just really displacement over the average velocity. Now, what is the average velocity? Our velocity initial is 0, our velocity final is 44, so we would have to get the average. So it would be 44 plus 0 divided by 2, so it's going to go ahead and give us an average velocity of 22 meters per second. So for part B, it's going to be our distance in which we're contact with, so that's 2 meters, 0.02 meters over our velocity, our average velocity, it is 22 meters per second. So we're going to go ahead and divide 0.2 divided by 0.02 divided by 22. It's going to go ahead and give us 9.0 times 10 to the negative 4 seconds. That's the amount of time. If you wanted non-scientific notation as a decimal, write it out, 0.0009 seconds. Alright, so it's a very short amount of time that the club and the ball are in contact with each other. Alright, next, part C. What is the average force acting on the ball? For part C, the force for impulse is really force times time. Alright, and impulse is equal to force times time. So we already solved for the impulse in part 1, it was 2.2. And so what we want to do is figure out the force, find the average force acting on it. So we're going to divide it by the time, the impulse over the time. So we're going to rearrange this formula, impulse over time, and that's going to go ahead and give us our answer. Alright, so that's going to go ahead and be impulse, it was 2.2 kilograms times meters per second squared, divided by the amount of time, which was 0.0009 seconds. And that's going to go ahead and give us the force. So 2.2 divided by 0.0009 seconds. It's going to go ahead and give us roughly 2,444 newtons of force. And that is the amount of force that the club's putting on the golf ball. That takes care of example 1. Next is problem number 1. In this question they ask us, what average club speed would double the average force? So now we want to go ahead and double the amount of force. So what will we have to do to the speed? To double the amount of force here, we need to double the amount of speed as well of the club. The initial speed was, the average speed was 22 meters per second squared. And that's how we got the average velocity initial plus velocity final over 2. Add them up, divided by 2 to get the average. So if we need to double the average velocity, therefore the new velocity that will give us twice the force would be twice as much as the original velocity. So it would be 44 meters per second. That would be the answer for this problem. In problem number 2, we're asked the following question. A 0.15 kilogram baseball is thrown at a speed of 40 meters per second. That we're going to say that's to the right, and that's the positive direction. And is hit straight back to the pitcher at a velocity of 50 meters per second. So that's going to be in the other direction, so that's going to be to the left. So our initial velocity is 40 meters per second to the right, and our final velocity is 50 meters per second to the left, so therefore it's got a negative. And in part A, they ask you to find the magnitude of the impulse delivered by the bat on the baseball. So we're going to go ahead and do that. Say, well, impulse is equal to our change in momentum. And our change in momentum is really momentum final minus momentum initial. We can go ahead and factor out the m's just to simplify the formula a little bit. So that's going to be our formula. All right, let's plug in our values. So for initial mass, well, the mass remains constant, 1.5 kilograms, multiplied times velocity final, which is negative 50 meters per second, minus velocity initial, 40 meters per second. So notice the signs, both are negative, so it's going to be negative 90.5 kilograms. And we just go ahead and multiply to get our answer. So it's going to be negative 13.5 kilograms times meters per second. That is our value for part A. In part B, we're asked find the magnitude of the average force exerted by the bat on the ball if they are in contact for only 2.0 times 10 to the negative 3 seconds. All right, so our time is really 0.002 seconds. Here's written out. There's the scientific notation. All right, so let's go ahead and solve for this problem. Find the magnitude of the force. All right, so we know impulse. Impulse is equal to force. Oops, let me rewrite that. Force times time. All right, so if you want the force, we're going to go ahead and divide both sides by the time. So we're going to end up with this formula. Force is equal to impulse over time, and that's going to go ahead and give us our force. So we can plug in our values. We know that impulse is negative 13.5 kilograms meters per second over time. The time is given to us, 0.002 seconds. So we go ahead and divide both of these to get the force. So it's going to go ahead and be 6,750 newtons of force. That takes care of part A and B on problem number 2. This also brings us to the end of this week's lesson, and thank you so much for watching.